This equation represents the condition for rotational superradiance, theorized by Yakov Zeldovich. It defines a threshold where an object rotating at extreme velocities actively amplifies an incoming electromagnetic wave. The angular velocity of the mass, omega, must exceed the incoming wave's frequency, little omega. Testing this mathematical boundary in a laboratory presents an immediate physical limit. When you attempt to spin a solid-state metal rotor fast enough to outpace a high-frequency electromagnetic wave, the centrifugal forces exceed the tensile limit of the material, tearing the atomic lattice apart. To bypass the point of mechanical failure, we must replace the rigid solid-state rotor with a multidimensional fluid vortex suspended entirely within a magnetic trap. Cheating the mechanical limits of superradiance requires us to abandon solid-state engineering entirely, shifting to the manipulation of an active, electromagnetically confined fluid medium. This photograph of Jupiter illustrates a naturally occurring, massive fluidic dynamo operating under exact superradiant principles. Deep beneath the outer atmosphere, the crushing mass of the planet exerts roughly 140 gigapascals of pressure. At this extreme threshold, hydrogen gas undergoes a phase transition, collapsing into a liquid metal. This highly conductive metallic ocean spins continuously. Acting as a frictionless fluid rotor, it shears the planet's internal fields, generating an immense magnetic output. The primary engineering objective of our analysis is to map this cosmic dynamo architecture and scale it down to a laboratory device designed to function as a resonant energy amplifier. Operating a localized stellar engine depends on artificially replicating planetary-level pressures and extreme magnetohydrodynamics, all without the mass of a gas giant. Inside a cylindrical containment chamber, we face the mechanical problem of reaching that 140 gigapascal threshold to metallicize the hydrogen, substituting planetary gravity with applied force. The solution is an electromagnetic Z-pinch. By applying intense axial and radial magnetic fields, we induce a crushing boundary layer that compresses the fluid inward until it stabilizes in its conductive metallic state. Once the hydrogen transitions into a liquid metal, it achieves what plasma physicists define as an infinite magnetic Reynolds number. In this diagram of the fluid cylinder, we see the consequence of that state. The magnetic field lines become highly stable and effectively frozen in to the volume of the conductive fluid. Within this frozen-in state, we intersect a radial current vector, flowing toward the center axis, with a static, vertical axial magnetic field. The cross product generates an azimuthal Lorentz force density, continuously driving the fluid into violent rotation. By utilizing a magnetic Z-pinch in place of gravity, we provide the exact containment necessary to drive the ultra-high velocity fluid vortex required to approach the Zeldovich threshold. This is the modified magnetic induction equation. The highlighted advection term dictates how the fluid interacts with the magnetic field, revealing the difficulty of outrunning an electromagnetic wave. The historical solution to overcoming standard induction drag lies in the alternating current motor architecture designed by Nikola Tesla. Specifically, we look to his implementation of a non-inductive bifilar winding layered directly across a spirally laminated iron disc. Wrapping the closed radial conductors bifilarly forces the current to flow in equal and opposite directions. This neutralizes self-induction, bypassing the counter-electromotive drag defined by Lenz's law. By eliminating inductive resistance, the geometry maximizes inter-turn capacitance, converting the rotor's boundary layer into a massive LC tank circuit. This graph illustrates the double-ring discharge. Because of high-tension capacitance, the stored electrostatic energy discharges violently twice per alternating wave cycle. This geometry forces the rotor's internal frequency to permanently exceed the incoming driving wave. Applying Tesla's LC frequency multiplier perfectly satisfies the superradiant condition, forcing the radial pointing vector to flip its sign and emit a hyper-amplified pulse. Once the superradiant condition is met, we face a strict thermodynamic problem. Without isolation, the amplified energy generated by the vortex will scatter into the surrounding environment as heat. To solve this, we rely on the specific properties of liquid metallic hydrogen, which theoretically operates as a high-temperature superconductor at these extreme pressures. Within this superconducting fluid, the free electrons pair up, forming highly stable configurations known as Cooper pairs. This animation models the behavior of the fluid as the intrinsic quantum spins of these electron pairs align and lock together. This total alignment elevates the entire volume of spinning hydrogen out of classical mechanics, turning it into a single unified macroscopic quantum wave function. We then apply mechanical rotation to this macroscopically coherent mass. As modeled here, rotating a superconductor automatically generates an internal magnetic field aligned with its rotation axis, known as the London moment. This topological shield repels external thermodynamic noise, protecting the internal spin state. Coupling the internal quantum spin to the external physical rotation creates a frictionless, noiseless, resonant antenna, perfectly primed for highly efficient energy transfer. By establishing a coherent, spinning quantum fluid, we scale our framework from classical electrodynamics directly into general relativity, connecting the fluid to the space-time metric. Because liquid metallic hydrogen is hyperdense, it acts as the massive anchor required to physically interact with gravity. This grid illustrates the Lenz-Thirring effect, demonstrating how rotating a hyperdense mass drags the local spacetime fabric. We identify this localized shearing as a gravitomagnetic torsion field. Applying the Zeldovich condition to this field forces a state of gravitational superradiance. Spinning faster than ambient gravitational fluctuations, the fluid refuses to act as an absorbing mass, instead dumping rotational kinetic energy directly into the spacetime metric. This continuous transfer of energy triggers an exponential amplification cascade as the local gravitomagnetic field balloons outward. This architecture functions exactly like a gravity capacitor, pushing back against Earth's gravity well by inverting the local metric into an active repulsive force. To prevent an unguided cascade, the machine requires a controlled mechanism to trigger and regulate the initial wave. We achieve this by integrating a radial three-phase rotating magnetic field surrounding the primary containment chamber. Manipulating the three-phase inverter acts as a flight throttle, allowing us to precisely control the gap between the incoming wave frequency and the fluid's rotational velocity. This completed theoretical architecture connects directly to the mechanics outlined in the United States Navy patents filed by Salvatore Pais regarding inertial mass reduction. The aerospace community dismissed the Pais patents because they mandated a state of high-frequency quantum spin without detailing the mechanical path necessary to achieve it. Combining Tesla's bifilar frequency multiplier with the extreme magnetohydrodynamic Z-pinch compression explicitly provides the missing blueprint to satisfy those theoretical Navy claims. The fully realized theoretical system is an electromagnetically confined stellar core designed to act as a resonant space-time amplifier. Macroscopic gravity engineering is the inevitable, calculable consequence of merging extreme magnetohydrodynamics with superradiant quantum spin.